Hi everyone, now we are at unit number 3, sequences and series, lecture number 2. So in the last lecture we have seen the convergence and divergence definition. Okay. So the sequence of real numbers an converges to a finite number L, it should be finite number. If for every epsilon greater than 0 there exists a natural number n such that modulus of an minus L should be less than epsilon for all n more than or equals to n. What is meant by this n more than or equals to n? We have seen already in the last class. So that n will depend upon epsilon. If you choose the different epsilon, then n will change. Already I told you in the last class for the sequence 1 by n. Okay, for different epsilons, different capital n's existed. That's why this n depend on epsilon. So we say that such a sequence diverges if no such finite number L exists. Okay, finite number L not existing, then the given sequences diverges. If finite number L existing, then the given sequences converges. That's it. If an converges to L, then we write limit n tends to infinity, the nth term of the sequence will be L. We need to apply the limit to the nth term, then the number will be L, that is called limit of the sequence. Or an converges to L as n tends to infinity. You can read this one as an converges to L. Okay, let me an sequence an. Its meaning is like the sequence an converges to L. So this meaning is that this is symbolic meaning. This is in what sequence an converges to L if an tends to L as n becomes large, and call that L is the limit of the sequence an. This L is said to be limit of the sequence. Why? Because limit n tends to an is L, right? So therefore this L is called limit of the sequence an. Now let us look at some observations on this definition. The natural number n depends on epsilon. Just now we discussed about it. And second one, this I told you in the last class, modulus of an minus L less than epsilon means uh, an is lies in the interval n minus epsilon to L plus epsilon for all n more than or equals to n. The limit of a convergence sequence is unique. Here the limit value is L, and this value should be unique if it exists. So more than one does not exist. Okay, if it is existing, then that cannot be called as a limit. Okay, if more than L, more than two limits are existing, more than two numbers are existing, for example L1 and L2, let's say, and that numbers cannot be called as a limit of the sequence. Okay, if one exists, then only that is called limit of a sequence. That is called the limit of a convergence sequence is unique. It is unique. Only one limit exists. And sequence is said to be convergent if it is converges. Same, the sequence is said to be divergent if it is diverges. Okay. Next one. Let's have some problems. Find the convergence and divergence of the following sequences. Let us find the convergence status of this. Okay. So first one, at what number the given five sequences converges. So first one, so let us call the sequences some an, sequence name. Okay. So sequence an is n plus 1 upon n. So this is a sequence. Okay. And what is the limit of this sequence, or at what number this sequence converges? So simply you need to find the limit. So limit n becomes large, an. So the geometrical meaning of limit or convergence means what? As n becomes large, what is the number of that sequence indirectly? For example, n is equal to 1. What is this number? If n is equal to 1, substitute here 1 plus 1, 2 by 1. So n is equal to 1, it is 2 by 1. That means first number is 2 by 1. What is second number? Substitute a2. So n is equal to 2. Substitute n is equal to 2. Then we will get 3 by 2. So second number of the sequence is 3 by 2. Like that, as n becomes large, what is the number of that sequence? That is the meaning of limit n tends to an. So limit n becomes large. Now an is n plus 1 upon n. Okay, n plus 1 upon n. Now this will be limit n becomes large, n plus 1 by n. So if you separate it, you will get 1 plus 1 by n, right? 1 plus 1 by n, like this, n by n plus 1 by n. See, don't do this mistakes. Seen so many times from the students. N plus 1 by n, you can write this one as n by n plus 1 by n, but this one you cannot write like that, n by n plus 1. N by n plus 1, you don't write n by n plus n by 1. Don't do this simple mistake. This is not equals to. Okay, don't do this mistakes. Generally you will do it. This is absolutely wrong. Okay, this is wrong. It is not equals to. Okay, this one is correct. So what is this value now? Limit n tends to infinity, 1 is 1 only, plus 1 by infinity. Now what is this value? 1. 1 by infinity is 0. So therefore this sequence converges to 1. So therefore I can, in symbolic form, n plus 1 by n plus 1 by n is sequence n plus 1 by n is converging to L, right? L is equal to 1 as n becomes large. So this is a way of writing, or simply therefore the sequence n plus 1 by n is converges to 1. You can write like this. All these are similar. Okay, all these are similar. Converges to 1. Or you can write like this. Or the sequence convergence of a sequence. So similarly, the second problem, 1 upon 2 raised n. Okay, 1 upon 2 raised n, second one. It is called that sequence is Bn. Okay, sequence Bn is 1 upon 2 raised n. Okay, now again same story, limit n becomes large or n tends to infinity, nth term of that sequence we need to calculate. So limit n tends to infinity, the nth term of the sequence is 1 upon 2 raised n. So now this is 1 upon 2 power 8. Again we should not write limit, already applied here. Now 2 power infinity is infinity, so 1 upon infinity, so that value is 0. So it is a single finite number, right? So this is a finite number. Okay, it is a finite number. Once it is a finite number, then only the sequence converges. If it is not a finite number, the sequence is diverges. Similarly, go back. So here also, so it is finite number, right? Let me write here. So it is a finite number. 1 is a finite number. So according to definition, it should be finite number. Limit should be finite number. If limit is not finite number, the sequence is diverges. Okay. So therefore here also I got finite number. So therefore conclusion is, so therefore the sequence 1 upon 2 raised n, 1 upon 2 raised n converges to 1 as n becomes large. You can write like this, or simply we write 1 is the limit of the sequence. You can write like this also, 1 is the limit of the sequence, 1 upon 2 raised n. Okay, therefore sequence 1 upon 2 power n is convergent sequence. Similarly, the third problem is minus n raised to, minus n raised to and minus 1 raised n. Okay, minus n raised to. So roughly I will do here now. Third one, sequence an is minus n raised to. Okay, now let us apply the limit. So directly, so limit n tends to infinity minus n square. So directly I am doing. So it is minus infinity. So therefore this is not finite. Not finite. It should be finite, but it is not finite. So therefore conclusion is, so therefore limit does not exist. Simply limit does not exist. Does not exist. If it is finite number, then only limit exists. Okay, since it is minus infinity, it should be finite, but it is not finite, therefore limit does not exist. Therefore sequence minus n square diverges. That's it. Okay, similarly fourth one, sequence an, or simply minus 1 whole raised n, right? Minus 1 whole raised n. Okay, now so limit n becomes large an. Now limit n becomes large minus 1 whole to the power of n. Now what is this value? You will get two values. Okay, two values. If this infinity value is even number, then will be plus 1. If n is even number, n is odd. N is odd number. So therefore two limits are existing, but I want only one finite number, right? Only one finite number. So therefore clearly here what can I say? So conclusion is, so therefore one finite number not existing. Okay, not existing. Therefore sequence minus 1 whole to the power of n is diverges. That's it. Or not converges. We can write not converges, or sequence minus 1 whole to the power of n is diverges. You can write like this. Diverges. Okay. So similarly, fifth one, last one, sequence 1/3, just 1 by 3. Okay. So limit n tends to infinity an. Assume this is a sequence which is an, right? This is a sequence which is an. Okay, an. So now this will be, so limit n becomes large. N becomes large. N is 1 by 3. What is limit n tends to be 1 by 3? There is no n here, right? It is independent of n, therefore directly 1 by 3 will get. But this is a finite number, right? So this is a finite number. Only one limit existing. So previously two limits are existing, but only one limit should exist. Okay, that should be finite number. So therefore conclusion is, so therefore sequence 1 by 3 converges to 1 by 3. So indirectly, let me elaborate more. So can you guess the terms of this sequence? If n is equal to 1 by 3, n is equal to 2, again 1 by 3, because there is no n inside, right? N is equal to 3, again 1 by 3, n is equal to 4, again 1 by 3, n is equal to 5, again 1 by 3, like that. So at each and every index the number will be 1 by 3 only. That's why as n becomes large, what will be the number? 1 by 3 only. That's what. Okay. So similarly here, as n becomes large, can you guess what are the terms of this sequence? If n is equal to 1, it will be minus 1. If n is equal to 2, it will be minus 4. N is equal to 3, it will be minus 9. N is equal to 4, minus 16. N is equal to 5, minus 25, like this, right? Up to so on. So like that, as n becomes large, it will be minus infinity square. That will be minus infinity only. That's why as n becomes large, the last term will be minus infinity. As n becomes large, not last term, as n becomes large, the number will be infinity, minus infinity of this sequence, which is not finite, therefore the sequence is diverges. So this is about convergence of a sequence or finding the limit of the sequence. So here the limit will be 1 by 3. So in this I can say that when now every constant sequence, every constant sequence. So example number 5, problem number 5 is a constant sequence because every time 1 by 3 only, right? Every constant sequence is, or let me write what is that, every constant sequence which is let me write C only, C, sequence C, okay, is converges to C, that number only, right? This number C only. Look at C is like 1 by 3 and this is converges to 1 by 3 only. That's what I proved here. Okay. Next one. Subsequence definition. Sequence and subsequence. Okay. The sequence, subsequence can be obtained from the sequence only. If you know sequence, then only subsequence can be obtained. Okay. It is like a child of sequence. Subsequence is a child and sequence is a mother. Okay. So if n is running from 1 to infinity is a sequence of real numbers, and nk, where the index k running from 1 to infinity, that means n1, n2, n3, like that, okay, is again a sequence of natural numbers such that n1 is less than n2 is less than n3 up to so on. So like that these numbers are arranged. Which numbers? This sequence, second sequence numbers. Okay. So therefore, if you elaborate this sequence, sequence nk, where k is running from 1 to infinity, k is running from 1 to infinity, what is this sequence numbers? n1, n2, substitute n, k is 1, k is 2, like that, n3, n4, up to so on. So these are the sequence of natural numbers. That is assumption in the definition. So these are sequence of natural numbers. But here what kind of numbers these are? n1 is less than n2, n2 is less than n3, up to so on, like that. So such kind of numbers these are. Okay. Then the conclusion is the sequence a n k. What is a n k now? A n k. Here k is running from 1 to infinity. Next k is 2, a n 2. Next a n 3. Next a n 4. Okay, and up to so on. So all these are the numbers of this sequence. And I can say that this sequence, look at here, the sequence a n k, k is running from 1 to infinity, is called a subsequence of a n. But how we are generating this? See, actually, look at the first sequence a n. What is n? Index n. N is a natural number. What about this sequence nk? Nk is also a natural number, right? K is running from 1 to infinity, you will get n1, n2, n3, up to so on, all those numbers. But what about this n1, n2, n3? These are natural numbers. But every natural number is a real number. That's different. Okay. So moreover, this index is again natural number. n1 is running from where to where again? 1 to infinity. 1 to infinity. So therefore, these numbers are obtained from the original sequence only. So your original sequence, let me discuss this. For example, look at this. Don't get confused. First sequence n is given to us. N is running from 1 to infinity. Okay. Now n is 1, a1. N is 2, a2. N is 3, a3. So like this. Okay. And how to generate the subsequence? Subsequence means, see, I will take only this term. See, subsequence means is not a new sequence. Subsequence is a child of the sequence an, but what kind of terms will be there in subsequence? The terms will be from an only. So this is a subsequence and this is a sequence. So this is a subsequence, this is a subsequence, and this is a sequence. How to get subsequence terms? The terms are from sequence only, but what kind of terms? You choose like this. I am choosing a1, a3, a5, a7, a9 like this. That means here, so therefore here my an1 means a1. So first term in the subsequence I am taking as a1, and second term in the subsequence I am taking as a3 now. So here my n2 is like 3. Understood? And third term I am taking as a5, and fourth term I am taking as a7. So like this I am taking. Okay, so like this I am taking, and now I am constructing as a new sequence which is called a subsequence. So up to so on. So therefore, what is the new sequence now? Subsequence. So subsequence a and k will be a1, because an1, right? an1 which is nothing but a1. Next an2 which is nothing but my a3. an3 which is nothing but my a5. So like this up to so on. So indirectly this subsequence is nothing but a1, a3, a5 up to so on like this. But what are these terms? These terms are nothing but coming from old sequence only. From this sequence only we are taking. Therefore, terms of a subsequence are not new terms. They are from the sequence only. But you have to choose different terms. See, I can take these terms also. You can take a2, next a3, next you can take a6, next a7, next some a10. You take this one. Now we can take that one more subsequence. Like I am calling the subsequence as b and k now. Okay, b and k, where k is running from 1 to infinity. Now what is k is 1? What is the number? B n1. B n1 I am taking as look at a2. I am taking a2. Okay. Now b n2 I am taking this one as some a3. Okay. Next b n3. B and 3. If we substitute k is 3, we will get B and 3. Now I am taking B and 3 as A6 here. Look at A6. Next B and 4. B and 4 I am taking as the A7. Like that. So up to so on. According to some rule you have to take this. Okay. So therefore indirectly this is nothing but A2, A3, A6, A7 and up to so on like this. So this is also one of the subsequence. So therefore, subsequence terms are nothing but from the sequence only. But according to some rule, we have to collect the terms. Okay. So therefore, here you look at n1 is less than n2 is less than n3. That's what you look at. N1 means what here? 1. N1 is 1. What is n2? N2 is 3. N3 is 5. So indirectly 1 less than 3 less than 5. Like that. Similarly here, what is n1? N1 is 2. So 2 less than n2 is 3. 3 less than n3, what is n3 is 6, 2 less than 3 less than 6, n4 is 7 like this. And these are natural numbers, n1, n2, n3, all these are natural numbers. This is a sequence an. Okay. So therefore, index n, instead of index n, you take odd numbers, a to n minus 1. A to n minus 1, if I take n is equal to 1, what will you get? N is equal to 1, you will get a1. N is equal to 2, a3. N is equal to 3, a5 like this. So this is one of the subsequence of this sequence. Okay, a1, a2, a3, okay, a4 and up to so on. This is original sequence. Okay, this is original sequence, and this is one of the subsequence. Is a subsequence. Is a subsequence. Subsequence of the given sequence an. An is main sequence. Similarly, can you generate one more? Yes, you can take odd places terms. A2 n log. Now n is equal to 1. A2. Compulsory n should run from 1 to infinity only. Index. Okay. N is 1 is 2. Next n is 2, 4. A4. Next n is equal to 3, A6. N is equal to 4, A8. So like this. So up to so. Again these terms are from old sequence only, right? A2, A4, A6, 8. All these are from here only. So this is a subsequence. Is a subsequence. Is a subsequence of an. Of an. Not only 2n minus 1, you can take 5n minus 1 also. You can take 5n minus 1. Accordingly, n is equal to 1 you have to write. If you take 5n minus 1, what is the first term? 4. 5n minus 1. N is equal to 1, you will get 4. N is equal to 2, you will get 9. Like that. N is equal to 3, 14 like that. So accordingly, you can generate. So that is one more subsequence of the sequence. So many subsequences exist. If you change the index, if you replace the index by any other form like this 2n minus 1 or 2n like this, then the resultant sequence becomes subsequence of the original sequence. Let us do some theorems based on this subsequence. Now, theorem number 1. The sequence an converges to L if and only if every subsequence of an converges to L. Okay, if an converging to n, say for example, if sequence an is converges to L, so this is given to us. If this is happens, if and only if, then every subsequence of an also converges to L. Now give me one subsequence. So then one subsequence is, let us write a to n minus 1. So this is one of the subsequence of an, and this is also converges to L. Not only that, you can write a to n also. So a to n converges to L. Next, a 2n plus 1. This is also one of the subsequence, and this is also converges to L. And a 5n minus 1. Your wish. This is also converges to L. Like that, every subsequence, look at the word, every subsequence of an converges to L, provided if the sequence an converges to L. Okay, next one, theorem number 2. So if the subsequences a to n minus 1 and a to n of a sequence an converges to the same limit L, that means a to n minus 1 converges to L and a to n is converges to L. That means two subsequences are converging to the same limit, then the sequence an converges. This is obvious because it is if and only if statement. Look at here, same statement only. If sequence an converges to L, then if and only if any two subsequences converges to same limit. If any two subsequences are converges to same limit, then what is the conclusion? Sequence n converges, because it is if and only if statement. That's what from here to, from right hand side to left hand side is this theorem statement. If the subsequences a to n minus 1 a to n of a sequence converges to the same limit L, then the sequence, original sequence, converges to L. Okay. Next, theorem number 3. If they are converging to same limit L, then the sequence converges to L. It is fine. Look at theorem number 2. If the two subsequences are converging to the same limit L, then I can say that original sequence converges to the same limit L. If these two subsequences are not converges to the same limit, then that is theorem number 3. If two subsequences of a sequence an have different limits, let's say first subsequence of an converges to L1 and second subsequence of an is converges to L2, but they are not equals. They are converging to different limits. Then I can straight away I can say that the sequences diverges. Okay, so let us do one problem based on theorem number 3. Find the convergence status of sequence minus 1 whole to the power of n. So let us take the sequence. So now I am applying theorem number 2 or theorem number 3. If first I will generate two subsequences, then I will find its limits. If the two limits are same, then original sequence converges. If the two limits are not same, then original sequence is diverges. That's what. So let us take the original sequence an is minus 1 raise n. So this is the original sequence. Okay. Now I want convergence status of this sequence. So before that, what I have to take is, let us take two subsequences. So a to n minus 1. Now what is a to n minus 1? Wherever n, there you write 2n minus 1. Here a to n minus 1. What is the difference between these two? Instead of n, we have written 2n minus 1. Similarly, here also instead of n, you have to write 2n minus 1. That's it, nothing else. 2n minus 1. Okay. And similarly, a to n. One more subsequence I am writing. Second subsequence. Again, same, instead of n, you have to write 2n. So minus 1 whole to the power of 2n. So these two are the subsequences of or two subsequences of the original sequence an. Okay, two subsequence of an. Now according to theorem number 2 or theorem number 3, so we have to find the limits, right? We need to find the two limits of these sequences. So first one, so limit n tends to infinity a to n minus 1. Okay, that means nth term of that sequence is a to n minus 1. N becomes large. What is a to n minus 1? It is minus 1 whole to the power of 2n minus 1. Can you guess what is this value? Limit n tends to infinity. What is this value? Minus 1 whole to the power of 2n minus 1 is always minus 1 only. Isn't it? Check once. 2n minus 1 is odd number. If n is 1, you will get minus 1. If n is 2, 4 minus 1, 3. So minus 1 whole power 3 is minus 1. If n is 3, 6 minus 1, 5. So minus 1 whole to the power 5 is minus 1 only. So whatever natural number n you substitute, this value is always minus 1. Therefore, instead of this number, I am writing just minus 1. Now limit, it becomes constant sequence. Limit n tends to minus 1 is just minus 1 only. So this is L1. This is first limit L1. Look at theorem number 3. Okay. Next limit n tends to infinity. Look at second subsequence. A to n. Nth term of the second subsequence is a to n. Now limit n tends to infinity, or n becomes large. What is a to n? Minus 1 whole raised to n. Now, what is the value of minus 1 whole raised to n? Whole power 2n, since it is even number, minus 1 whole to the power of even number is always plus 1 only. Now this becomes constant sequence, so it is 1. Now this is L2. Look at, from these two I can say that L1 is not equals to L2. So therefore, by theorem number 3, the sequence minus 1 whole to the power of n diverges, or simply not converges, whatever. See, I have done already this problem. Look at problem number 1. This is problem number 2, right? Look at problem number 1. Same problem I have taken. But there I got two limits. If n is even, I got plus 1. N is odd, I got minus 1. So two limits are existing. Therefore, diverges I have written there. Check once. So same problem. This is by second method, by subsequence method. You construct any two subsequences, and after that, at what number the two subsequences are converging, you find out. If the two limits are same, then the original sequence, this one is converges. If the two limits are different, then the original sequence is diverges. Let me do one more problem for more clearance. Look at problem number 3. Find the convergence status of this minus 1 whole to the power of n minus 1 divided by n. Okay. So again same. You find the two subsequences. So given sequence is, let us divided by n. Okay. Now let us generate two subsequences. Or directly you can find the limit. Limit n tends to infinity. So first method, you find the limit of this sequence by limit concept. If you are able to find the limit, that is fine. Limit n tends to infinity bn. If you are unable to find the limit, then go to the second method, that is subsequence method. That is second method. So limit n tends to infinity. What is bn? Minus 1 whole to the power of n minus 1 divided by n. You can do like this also. Okay. If you are able to find limits, it is fine. If you are unable to find limits, then go to the second method. If n becomes infinity, if infinity is an odd number, you will get different value. If infinity is an even number, you will get different value. Okay. If infinity is an even number, for example, if it is even number minus 1 is odd number. So minus 1 whole to the power of odd number is minus 1 divided by, what is n? N is even number, right? So large even number. So this will be, what can I say? 0. And what about this? If n is odd number minus 1 is even number. Minus 1 whole to the power of even number is 1 divided by odd number. N is odd number. So that is infinity, which is odd number, that is 0. We are getting same. So limit is same, 0. Therefore the sequence is converges. And which is finite number, right? So this is finite number. So if you are confusing with such kind of analysis, then what to do? Simply straight away go to the subsequence method. So you can do like this also, no problem. So therefore the sequence is converges. Conclusion. Therefore the sequence minus 1 whole raised n minus 1 divided by n, and this sequence is converges to 0. That's it. Okay, and you can do like this also by second method, by subsequence method. Let me keep the generate two subsequences. First I am writing b2n minus 1. This is first subsequence of the original sequence. Now what is b2n minus 1? Wherever n, there you write 2n minus 1. So minus 1 whole to the power of minus 1 whole to the power of wherever n, there 2n minus 1. So 2n minus 1 divided by 2n minus 1. 2n minus 1. Okay, and which is nothing but minus 1 whole to the power of 2n minus 2. That means 2 of n minus 1 divided by 2n minus 1. Okay, but what is this actually? Keep on simplifying. Minus 1 whole to the power of 2 into something, right? So 2 into something is which is even number. Minus 1 whole to the power of even number is 1 only divided by 2n minus 1. So indirectly the first subsequence is 1 by 2n minus 1 only. Now let us generate the second subsequence, which is b2n. Okay, and now wherever n, there you have to write 2n here. First one, look at here. This is bn. Instead of n, you write 2n. So minus 1 whole to the power of 2n minus 1 divided by, instead of n, 2n you write. Just to look at the changes, bn and b2n. b2n, bn means instead of n, 2n only. So in the original sequence also, instead of n, you write 2n only. Here 2n and here 2n. That's it. And this one you keep on simplifying. What is minus 1 whole to the power of 2n minus 1? 2n minus 1 is odd number. So minus 1 whole to the power of odd number is minus 1 divided by 2n. This is second subsequence. Now let us find the limits for those subsequences. So therefore limit n tends to infinity. Okay, n tends to infinity b2n minus 1. b2n minus 1. And what is this? So limit n tends to infinity. Okay, now what is b2n minus 1? 1 by 2n minus 1. 1 by 2n minus 1. This is 1 by 2 into infinity is infinity minus 1. So 2 infinity minus 1. Answer is 0. Similarly, second limit, second subsequence limit. So limit n tends to infinity b2n, nth term of the second subsequence. So limit n tends to infinity. What is b2n here? b2n is minus 1 upon 2n. Minus 1 upon 2n. This will be minus 1 upon 2 into infinity. Substitute n is infinity. Now what is this value? Again 0. You get minus 0, but 0 neither positive nor negative. Therefore I can write directly 0. So look at both the limits are same. So call this one as some L1. First subsequence limit is L1. Second subsequence limit is L2. But the limit is same. L1 is equal to L2. Therefore by theorem number 2, conclusion. So therefore by theorem number 2, the two subsequences converges to the same limit. Converges to the same limit. Same limit L. Therefore the sequence, what is that? Minus 1 whole to the power of n minus 1 divided by n. Okay, converges. That's it. So it is converges to 0, you can write, because two subsequences converges to 0. Therefore original sequence also converges to 0. So this is second method. By using subsequence technique. Okay, concluding the convergence and divergence of the sequence by using subsequence technique. Let us do the third problem. Find the convergence status of n plus 1 by n. Again same first method. By first method you can do, let me do quickly. By first method what to do, just you find the limit. So limit n tends to infinity an. So assume the sequence is an. So limit n tends to infinity, what is an? Nth term. That is n plus 1 by n is the nth term. This is nth term formula. And this will be, so limit n tends to infinity, limit n tends to infinity, this will be 1 plus 1 by n. Okay, 1 plus 1 by n. Now this will be 1 plus 1 by infinity. Now this will be 1. So which is finite number. And single limit existing, finite number. Therefore the sequence converges to 1 straight away. Okay, I can write like this, converges to 1 as n tends to infinity. You can write like this, or simply limit of the sequence is 1, your wish. So by first method we concluded the sequences converges. Okay, second method, by second method, subsequence method. Second method can conclude like this also. You better go to second method if first method is you are unable to find the limit. If you are unable to find the limit in first method, go to second method. Yeah, in second method you find two subsequences. So directly I am writing. So a2n minus 1 first. a2n minus 1. What is a2n minus 1? Instead of n you write 2n minus 1. So 2n minus 1 plus 1 by 2n minus 1. Look at the original sequence. So this is the original sequence. Okay. N plus 1 by n. Instead of n here I am writing 2n minus 1. So 2n minus 1 plus 1 by 2n minus 1. And you keep on simplify this. So which is 2n by 2n minus 1. 2n by 2n minus 1. This is the first subsequence. And what about second subsequence? A to n. Okay. Now, what is a to n? Instead of n, you write 2n. So 2n plus 1 by 2n. This is second subsequence. Now let us find the limit. So limit n tends to infinity a to n minus 1. Now limit n tends to infinity a to n minus 1. How much? 2n divided by 2n minus 1. 2n divided by 2n minus 1. Now this will be limit n tends to infinity. Okay. Let us find the limit for. Okay. So numerator you take n out. So if n is out, so n into 2 divided by denominator 1, n is out. N is out. So 2 minus 1 by n, because n is our variable. So this n cancel out. So limit n becomes large. What will get? 2 upon 2 minus 1 upon n. 1 upon n. Apply the limit now. 2 divided by 2 minus 1 by infinity, which is 1. 1 by infinity is 0, 2 by 2 is 1. So this is now, let us call this as L1. Okay. Similarly, next limit n tends to infinity a to n now. Okay. So limit n tends to infinity. What is a to n? 2n plus 1 divided by 2m, which is limit n tends to infinity. Let us take n common from the numerator. If you take n common, you will get 2 plus 1 by n divided by denominator also 1 n is there, so you cancel out with this n. Okay. What is left now? So then substitute back. So 2 plus 1 by infinity divided by 2. So this will be 1. Look at, again this is L2. Look at L1 is equal to L2. So therefore L1 is equal to L2. So again by theorem number 2, both the limits are same. Therefore original sequence is also converges to 1. Look at here also I got the sequence is converges to 1. So remember, if a sequence is converges, definitely it will be converges to a unique limit. Okay. If it is diverges, then it may converge to different limits. That is different issue. But once a sequence is converges, compulsory the sequence should converge to the same limit only. It will not converge to the different limits. For example, look at this problem only. I got the sequence is converged to 1 by first method. Look at by second method also the sequence is converged to 1 only. If you are getting different, for example, here 2, you are getting 2 and 2. That means your calculation is mistake. A single convergence sequence cannot converge to two different limits. It will converge to unique limit only. And with this, I will stop.